let's spend some time talking about the calibration curve. The calibration curve is the centerpiece of quantitation, and managing your calibration curve is really the essential part of quantitation. So let me demonstrate what capabilities we have in managing the calibration curve. Here's a fully analyzed batch, our drugs of abuse. Now, the typical situation is that you have the calibration samples in the batch. And in that case, I'll show you a mechanism here where I'll clear the calibration table. And by the way, you can manage that by compound. So I will just clear it for cocaine. And you'll notice that the calibration table disappears, and so do the results for cocaine, but the other compounds remain. So back to my original point, typically at the beginning you just have the calibration samples, and these calibration samples are used to build the calibration curve for this batch and this analysis. That is the typical scenario, and that would be done in the straightforward steps of extracting the signals, integrating, building the calibration curve, and then using that calibration curve to quantitate the results. So that's the norm of managing calibration curves, especially in LC-MS. All right, let's take the situation where we want to manage our calibration curve. Here I have drugs of abuse fully analyzed, and what I'll first do is I'll just clear the calibration, select all the compounds. Now there is no calibration curve present for any compound. Now, let's say I have run this batch today. Notice that I have calibration samples in this batch, but what I'd rather do is use yesterday's calibration curve. So I will open a method from an existing batch, and I will go to yesterday's batch, and I will get that method. That will take me over to the method editor, and I will apply that method to this new today's batch. Now, instead of analyzing, which will rebuild the calibration curve, notice I have the calibration curve from yesterday's batch. What I'm going to do instead is I'm going to quantitate the batch. Now, quantitation will only use the existing calibration curve and then create the quantitation results from that existing calibration curve. And that's what I've done here. Now let me go to cocaine and look at this particular signal at level 3. And for the sake of illustration, even though this point is perfectly good on the calibration curve, I'm going to manually integrate it and make it a value that is easily seen. And the purpose, as you can see, the final concentration here, let me give it a little bit of area. Okay, the accuracy is very low. Notice that the calibration curve did not change. What I'm going to do next is to illustrate that I can replace the calibration curve for a particular compound using the calibration samples in this batch. So I'll go ahead and do that. And notice that this point here, which I'm just going to re-enable now, has fallen off the line because it's manually integrated, but it has rebuilt this calibration curve and left the calibration curve for the other compounds from yesterday's batch. So that gives you a flavor of managing your calibration curve. You do not need to have calibration samples in the batch in order to use a previously existing calibration curve. Let's talk about another way to manage your calibration curve. Now, I've got the calibration curve that was created with that manually integrated point at level 3, which is far off the curve. And I just did quantitate the batch using that calibration curve. Now, Let's say that I do have calibration samples in my current batch. I have the choice of averaging. So averaging the calibration points will use the existing points that already are part of some previous calibration curve, for example, that manually integrated point, and add to that points that will be created from the calibration samples that are in the existing batch. And of course, I can manage that by compound. So for this case, I'll just do cocaine, and I will now add a point in for cocaine. This does not have the manual integration, so the point is right on the line. I can see the relative standard deviation bars calculated because I have 2 points now. One was from the original that was manually integrated, and one is from the calibration point that was created from this sample here, calibration level 3. This is a set of replicates here, and I can maintain adding replicates, which will be averaged as I add more and more replicates into the calibration table. And that's one way to manage your calibration curve over time. Thank you for your attention.